In the previous lectures, we have been studying about the basics of operating system, and we have seen things like computer system operations, and we have also seen structures like storage structures and input-output structures. Now in this lecture, we will be studying about computer system architecture and mainly about types of computer systems based on number of general purpose processors. That means we are going to study how we can categorize computer systems based on the number of general purpose processors that they use. Alright, so let's see how we can categorize our computer systems based on the number of general purpose processors that they have. So first of all, we have single processor systems, which from the name itself you may already have understood that it has only a single processor. And then we have the multiprocessor systems in which there are two or more processors. And then we have the clustered systems in which two or more systems are coupled or clustered together in order to perform certain tasks. Now let us explain each one of these systems and see what are their differences and what are the advantages of them and what are the types of these processor systems that we have. So first of all, we have the single processor system. So in the single processor system, one main CPU capable of executing a general purpose instruction set, including instructions from user processes, is present. That means in the single processor system, we only have one main CPU which is capable of executing the general purpose instruction sets as well as the instructions from the user processes. Now, other special purpose processors are also present which perform device specific tasks. Now in the single processor system, apart from the main CPU, there are also other processors which are present which does not do the general purpose task, but it performs some device specific tasks. Now what do we mean by this? This means that we have certain devices in our computers like our keyboard, our disk and so on. So for all this, there may be some microprocessors which is specified to do a specific task related to that device. Like for example, let's say that we have our keyboard. Now when you press a key on your keyboard, the keystroke has to be converted to some kind of code. Let's say a binary code, so that the computer actually understands what you have pressed or what you are typing. So in order to convert that keystroke to a code, there is a little microprocessor present on your keyboard which is going to perform only that task of converting your keystrokes to some kind of codes. Now those are the special purpose processors that we are talking about. So these kind of special purpose processors are also present, but they are not for general purpose but for specific purposes. Now you may question me saying that I said it is a single processor system, but here I have already showed you more than one processors. I said that there is a general purpose processor and also special purpose processor. Yes, that is right, but the answer to this is that we give the name to these processor systems based on the number of general purpose processors that we have. So even though there are special purpose processors which perform some little task specific to the devices, but since we have only one general purpose processor, we call it a single processor system. So that is why we call it single processor system. Alright, now let's go to the next one. So the next one is multiprocessor system. So from the name itself, we can understand that in this there will be more than one processors, or we can say there are two or more processors. And also it is known as parallel systems or tightly coupled systems. So these multiprocessor systems are also known as parallel systems or tightly coupled systems, and these two terms we will be discussing later as we move ahead in this subject. So these multiprocessor systems, they have two or more processors in close communication, sharing the computer bus and sometimes a clock, memory and peripheral devices. So unlike the single processor system which had only a single processor, in this multiprocessor system we have two or more processors which are closely communicating with each other because they need to work together to perform certain tasks. And what are those tasks? They may be a single task or different tasks depending on the kind of system that we have. So in order to work together, they need to have a close communication and synchronization with each other. So that is why we say that they are in close communication and they also share the computer resources that we have. Now let us see what are the advantages of having these multiprocessor systems over single processor systems. So coming to the advantages, the first advantage is increased throughput. So throughput is something that we can use used to measure the performance of our system. So sometimes it is also known as the amount of data that can be transferred from one location to another. So throughput is like the measure of the performance of the system. So we can say that in multiprocessor systems, we will have increased throughput or increased performance. And why is that? The answer is simple. That is because we have more than one processors which will parallelly do our work, and it will make it faster and more efficient. So that is what we mean by increased throughput. And then the second advantage is economy of scale. Now, why do we call it economic? I say that multiprocessor systems are more economic as compared to the single processor system. And that is because in multiprocessor systems, we have these different processors sharing the resources of our computer or our system. But in case of single processor system, if you want to have the same amount of power, you may need to have multiple single processor systems with their own individual resources. But here we see that we have multiple processors sharing the resources. So in that way, we can have economy of scale. That means it is more economic as compared to single processor system. So if you have a multiprocessor system with 3 processors, and if you want to have the same kind of setup in your single processor system, you may need to have 3 single processor systems, 3 individual single processor systems with their own individual resources. So we see that this is more economic. And then the other advantage is increased reliability. Now this is more reliable as compared to single processor system. And why is that? The reason is again the same. That is because we have more than one processors. And why is it reliable? That is because in this multiprocessor system, even if a single processor fails, we still have other processors which will back us up and which will still keep us running. So let's say that you have 10 processors in your multiprocessor system, and let's say that one of them fails. So even if one of them fails, the remaining 9 can share the work that was being done by the one that is failed, and without giving you a complete failure, your system will still work even though the performance may reduce a bit. But in case of single processor system, if your single processor fails, that means it is a total failure. Your whole system breaks down. But in multiprocessor system, even if one fails, the remaining can help to get the work done without causing a total failure of the system. So that is why we say that it is more reliable and it has increased reliability as compared to the single processor system. Alright, so those were the advantages of multiprocessor systems. Now let us see what are the types of multiprocessor systems that we can have. So basically there are 2 types of multiprocessor systems. First one is called symmetric multiprocessing, and the second one is asymmetric multiprocessing. Now let us see what are the difference between these 2 type of multiprocessing systems. So in symmetric multiprocessing, we have our different processors. Here CPU 1, 2 and 3 denotes the different processors that we have, and processes P1, P2 and P3, these denotes the processes that has to be executed. Now in symmetric multiprocessing, all these CPUs or all these processors, they are actually the same. That means they are similar to each other and they all participate in performing these tasks or processes P1, P2 and P3. So all the CPUs are involved in all these tasks. So that is known as symmetric multiprocessing. Now in asymmetric multiprocessing, unlike this one where the CPUs 1, 2 and 3 were similar to each other, here we have a master-slave approach. So here these boxes denotes the CPUs. So one of the CPU or one of the processor will act as a master and the remaining processors will be slaves. So the master, what it does is it monitors these other processors and it assigns the tasks for these processors. So the master is like a monitor which is guiding or supervising these other slaves, and then the slaves, they take care of particular processes. So let's say here slave 1 is taking care of process number 1, slave 2 for P2 and slave 3 for P3. And we see that slave 1 is only taking care of process P1 and process P1 is not taken care of by slave 2 or slave 3. So P1 is only for slave 1. And so is P2 and P3 for slave 2 and slave 3 respectively. And here also if something fails, the master will take care of how to distribute the load after one fails and things like that. So the master is the monitor and the rest are the slaves. But in symmetric multiprocessing, we see that there is no master-slave approach, but all the processors are peers, or they are similar to each other, and they are all involved in all the tasks that is present. So that is the difference between symmetric multiprocessing and asymmetric multiprocessing. Now let us come to the next type of computer system that we have based on the number of processors, which is the clustered systems. So in these clustered systems, like multiprocessor systems, clustered systems gather together multiple CPUs to accomplish computational work. So this is also somewhat similar to our multiprocessor systems. So here the clustered system, they gather together multiple CPUs to accomplish computational work. Now you may be thinking, if that is the case, then what is the difference between multiprocessor system and clustered systems? So the difference is that they are composed of two or more individual systems coupled together. So in multiprocessor system, what we had was two or more processors. So only the processors were the multiple things that we had. But in clustered system, we have the complete system that is coupled together. That means two or more individual systems. That means complete systems, not only the processor, but the complete systems are coupled together and they form a cluster. So that is what we mean by this clustered systems. So this system, it provides high availability. Now you may have already guessed why it provides high availability. That is because we have more than one systems coupled together. So even if one fails, the rest of the systems together can take care of the task that was being accomplished by the one that failed. So you are not having a complete system failure even if one or two fails, because there are others that can take care of the system. So a chance of complete failure is very less. That is why we say that it provides high availability. And even in this clustered system, this can be structured either asymmetrically or symmetrically. So just like our multiprocessor systems, even this clustered systems, it can be structured either asymmetrically or symmetrically. So in asymmetric, what happens? So in asymmetric, one machine is in a hot standby mode and then the others run the applications. So we know that in asymmetric mode, what we are having is a master-slave approach. So even in this one machine, it is in a hot standby mode, so that is like the master, and then the other systems, they run the applications. So this machine in hot standby mode, what it does is it monitors the other servers or the other systems which are running, and if it finds that some of them fails, or if let's say if one of them fails, this machine in the hot standby mode will take its place. So one is monitoring and the rest of them are running. And then in symmetric mode, what happens is two or more hosts run applications and they monitor each other. So unlike this where one is monitoring, here all the systems or all the hosts that are there, they are running the applications or they are involved in certain tasks, and instead of one system monitoring everyone, here all the systems, they monitor each other. So if you think which is better, asymmetric or symmetric, obviously it is a symmetric one. That is because here all the resources can be shared and used efficiently as compared to the asymmetric structuring. So that was about the clustered systems. So those were the types of computer systems based on the number of general purpose processors. We discussed about single processor system, multiprocessor system, and clustered systems. And we also saw the advantages of one over the others, and also we have seen the types of these systems that we have. So I hope you understood these types of computer systems based on the number of general purpose processors, and I hope this was clear to you. Thank you for watching and see you in the next one.